G'day YouTube, JB from Oz here. Just a quick update on the SPI angle and radius dressing tool that we bought at auction. This is what it used to look like. Kind of looked like an honest piece of stuff. Done a bit of work on it today. And this is what it looks like now. So let's have a quick look through what it does. Alright, so we don't know too much about it, but what we've managed to learn so far is a few fairly important things. This top lock allows us to stop the spindle rotation altogether. We've managed to uncover a mark and an oil line. When those two are lined up, there's a small grub screw here, and that lines up with oil channels such that you can oil the internal bearings of it. So that's an oil hole. At the back we have adjustable cams to allow us to set angles. So let's say for instance you wanted to go to an angle of 30 degrees in one direction. You would bring in the lock, set the stop, actually, yeah, this one here. Let's go the other way. So we want to get to 30 degrees. We'll use the vernier there to set it onto 30. Lock our stop. So that means we can repeat to 30 degrees each time on that angle. Same the other side. So the pin allows you to angle from one direction and angle to the other direction. We believe that this is a jacking screw. Essentially that looks like it puts a preload on the back end of this casting once it's bolted down, such that there'd be less vibration. So at whatever point we're working to, that's really all we can see that as doing. On a later picture of a later model we see that that's actually integral to the casting, so we think that's possibly what's happened there. We've got an adjustment screw here which allows us to gently clamp on this rear collar, and that adjusts the preload of the two cone metal to metal bearings inside the spindle. We have two screws here. The rear screw is on a ball bearing, the front screw is a clamp bolt. So with an appropriate tightening of the clamp bolt and a preloading of the ball bearing, you can get quite a lot of torque at a particular diameter through what is a split casting at the bottom. And there's a piece of material in that back casting there which is drilled and plugged, so there's a little bit of flex. So it looks like those two features are how you take up any backlash in the end float and also tighten up the rear of the spindle. To the front we've got 4 hexes which work on the gibs, which is part of what allows us, let me just lock the rotation, part of what allows us to travel left and right, and so you can take out some slop with those gibs there. There's a dowel and a couple of cams which allow you to lock into home position or adjust away from home by using a set of gauge blocks underneath this stack or a set of gauge blocks over this stack for concave and convex adjustments from center. There's also a lock screw here which stops that from moving. I believe this flat surface is where a standard would bolt. There's 2 small threaded screws and a pin, or else maybe it's just a through hole and 2 pins and a flat plate, which is how you would set the diamond to 0 on your rotation. We don't have that piece, so that's an assumption at this stage. There also looks to be a dowel pin and a clamp on the front for this nose, and I think this nose is actually replaceable as well. There is a split through and 2 clamps which should allow for that nose to come out all together for different grinding attachments. What else have we got? A couple of interesting things. We've got what looks to be a stepped dowel at the back here. Doesn't really look to be the same size as anything else. Maybe it's a diamond location so that you could store a spare diamond at the back of the casting, perhaps. But then what would you use this for? Maybe that's the standard? Who knows? Anybody out there who's got any info on it, please let me know. And
Do the angle dressing?
oh yes, so we've got the ability to set an angle. If we lock that in, lock our slide, we would go from one side around to another side. When you reach the end, you would then dress on an angle. There's a detent at the center. You'd come back to your other side, dress on an angle. That's quite an extreme angle, you wouldn't necessarily do that. There's also at the back here a set screw which, if you wind it in far enough, takes that center detent out of play so that you don't get a zero vibration as you travel across the center of that for just doing angle dressing. That's all the mysteries we've managed to figure out, I think.
Set the angle at the top.
This angle here.
Yeah, you'd set that angle, whatever angle you want.
Oh, if you're just wanting to do a particular angle.
Yeah, zero weight.
Okay, so the final thing you might want to do is set a tangent, and you would set your angle on the vernier at the top. Let's say we want a 15-degree angle. Looks pretty good. Lock that, and then with the detent out, you'd then be able to grind a 15-degree dress across the wheel. So that's what we've been able to figure out from just using it and cleaning it. If you've got any other information, or if you've perhaps got a manual for an SPI, Swiss Precision Instruments angle and radius dresser, I'd love to have a look. Thanks for watching, and click like and subscribe if you'd like to see more of these. Thanks, mate.